All right, welcome back to my TED Talk. Today, we're going to do 11 through 22. This is EOC Subpart 3. So you should be doing this either probably Friday or Monday. And I'm going back to number 10, which I worked on, of course, because it bothered me. So I had to figure out why. Let me see if I can get this straightened out here. That's a little better. I had to figure out why the bird is in the tree 150 feet up and he drops it to 140. So I was substituting 140 because I thought that was the change in the height. But the way to solve it is plug in 10 for the height, because at that point it's going to be 10 feet above the ground. The rose bush is obviously a very tall rose bush. So it's like this. You can subtract 10 from both sides. Plug that in your calculator, solve for the positive x value, or zero it out, and you end up getting 2.95. All right, on to number 11 we skipped, on to number 12, all right? On to number 12. Perform the indicated operation. This one's a very straightforward one. It just asks us to subtract the two functions. So we end up with x to the third. We're going to subtract that one from it. X to the third plus 3x. The only tricky thing about that is, remember, the second function needs to be in parentheses, in which case we distribute the negative or the minus sign, and we end up with minus 2x, which would give us plus x, and minus 1. So our answer will be C. All right? Let's check it. Yep, there it is, C. All right. Number 13. Now, I don't know if you remember this when we did multiple functions together or operations with functions, we did composite. So we're going to have to plug one function into the other. We plug the second function into the first function. So I'm going to write the first function, but instead of x, I'm going to write the second function. And then that's a minus 2. So all I did was replace that x with this entire function. All right, now we're just going to simplify. Minus 2x squared plus 6 minus 2, that gives us plus 4 here. Just for the sake of speed, should be negative 2x squared plus 4. So C we're going to go with on that one. And C is the correct answer. All right, number 14. Inverse of a function. You may recall, you may not. To find the inverse of a function, I think the calculator will do it, but we did not explore that when we were doing functions, and I have not looked at that. So we're just going to switch our x and our y. So I'm going to write x equals y minus 9 over 6. Remember, this was a y. F of x is the same thing as y. So I just switched x and y. We're going to cross multiply. 6x equals y minus 9. Y then would equal, add 9 to both sides, 6x plus 9. So, B. Let's double check that. There it is. Remember, even though I'm showing you guys the answer, you have to work it out on your paper. I got to see some work. I want to see that you're, anytime you are repeating the work, even if you're just writing what I wrote, then you are practicing that skill. Properties of rational exponents. We're going to determine the value of y for the function. Now, I will tell you that the 5 trick will work for this. You can plug in 5 here and here and here and see if we can get an equal value here. But the way to solve it, the actual way to solve it is to change all of these into functions that we can deal with, or exponents that we can deal with rather, and then get x equal to x on both sides, and then our exponents will be equal. So the top is x to the 8th to the 1/3 power. All I did was turn that third root sign into a 1/3 exponent over x. I'm just going to power to a power is multiply, so to the 4/3 power. So x to the 8/3 divided by x to the 4/3 is the same thing as I subtract powers when I divide. x to the 4/3 equals x to the y. When your bases are the same, the exponents are equal, so I'm going to go with D on that one. Let's double check it. Yep, there it is. All right. Number 16, Emmeline is working with one side. Her work is shown below. So let's see how she solved it. Most of the story in this one, you don't have to know what Pythagorean triples are or anything like that. Most of the story in this one is sort of a distraction. We're just going to do what she did to these polynomials and monomials. So we're going to go ahead and square the first one, which she's done here. We're just checking her steps. Square the first one, and then I always forget how to square a binomial, so I'm just going to write it next to itself, because squared is just times itself. And I'm going to double check. I'm going to go ahead and multiply. I'm going to FOIL this. 25 x to the 4th minus 25 minus 25 is going to give me minus 50x squared, and then plus 25. So from step 1 to 2, she made a mistake. She did not square that properly. So it's not entirely correct. There's a mistake in step 2, okay, maybe. And maybe step 4 also. Yeah, step 4, she made a mistake because those are not like terms. You can't combine those. So I'm going to go with number 3, C on that one. C is the answer. Mistakes in step 2 and step 4. All right. So average rate of change over the given interval. So this one was a little tricky for me because, again, we're dealing with these negatives, but basically I just want to plug in my -4, my -1, and my 1 into the equation. I end up getting 8 plus 6 minus 2, that's 14 minus 2 is 12, and then I'll plug in the 1, and I get 8 minus 6 minus 2, so 8 minus 6 is 2, minus 2 is 0. So I'm going from 12 to 0 when I plug in my x values. I'm going from 12 to 0. Since it's going down, I'm going to call the rate of change -12, and we're going to divide by this interval, which is only 2 units wide. Answer ends up being -6. All right. That one is a little confusing, but the answer ends up being D on that one. First time I solved it, I got +6, and then I realized it's dropping. So we got to call that rate of change -12. -12 divided by 2 is -6. All right, so I was working with this one for a few minutes earlier, and then I realized it is just synthetic division. We're dividing by a single binomial there. So I'm going to set up my synthetic division. Remember, divide by the opposite of the constant. 2, 5, 8. First step, drop down. Then it's mama. Multiply, add until you get a remainder. Drop down, multiply, -4, 1, multiply, -2, 6. There's my remainder. So it's equivalent to 2x plus 1, that's where that comes in, plus the 6 over what I divided by, x plus 2. So 2x plus 1, there it is right there. So number 3 should be the answer on that one. And it is. All right, 19. We only have 4 more to go on this set. How am I doing on time? This one's good. This one's good. These are going a little quicker. Which expression is not a solution to this one? Now, I was able to work out the first 2. Remember, teachers don't know everything, and teachers don't always see all the connections that they're supposed to see. That's why we refer to each other, all right? So what I did was, I turned it into logarithmic form. So the log base 2 of root 10 equals t. Remember, the answer is always the exponent. So that's one of our answers, log base 2 of 10. And then I can call, instead of log base 2 of 10, I can call, instead of square root of 10, I can call it to the 1/2 power. Any power you can pull out to the beginning, pull out to the front there. So that becomes another possible answer. And then I wasn't sure what to do with these two, to be honest. So what I did was I just plugged that in for t and plugged that in for t and solved and tried to find which one was equivalent to root 10. And the answer ended up being number 4 is the one that does not give you root 10 when you plug it in. You could have done that for all of these, by the way. If you were just totally unclear, you could have just plugged, that's just a number. Remember, a log is just a number. There's no variables here. So we can literally just plug that in for t, that in for t, that in for t, and that in for t, and see which one does not give us root 10. All right? Let's keep going. 3 more. What is the solution set? Okay, so for this one, I ended up square both sides to get rid of that root sign. I end up with this. I'm going to get everything over on the left side. Plug that in, zero it out. We end up getting no solution. Because that, oh wait, I'm sorry. I thought it was no solution. Let me plug it in again. I'll solve it on the fly here. X squared minus 3x minus 40. I end up getting negative 5 and 8. But because of the nature of square roots, you always want to check those possible answers. All right? So I ended up getting that as possible zeros. That's where it passes through the x-axis. But I'm going to check both answers. If I plug 8 in here, 8 times 3 is 24, plus 40 is the square root of 64, and then 8 does equal the square root of 64. But if I plug negative 5 in, I get negative 15 plus 40. Negative 15, and negative 5 does not equal the square root of 25. Positive or negative. Actually, if it was positive and negative, that would be a possible answer. So let's take a look and see if it is 1 or if it's number 2. It's number 2. So number 2 works. Just because of the nature of those square roots. All right? All right, consider the following patterns. Which pattern is geometric? Only one of these is geometric, I guess, because we only have, well, let's see. Do we have more than one possible answer? Does it ask? Consider the following pattern. Which pattern is geometric? All right, so we got to find out if it's geometric, we got to divide backwards, right? Just to make sure it's the same thing, times, times, times. Now, this one I already worked out. I divided each number, negative 6.75 divided by 9, it ends up being 0.75. So this one is geometric. This one's not. This one's adding 3 and then adding 5 and then adding 7. Not. This one's times 3 and then plus 12 and then plus another 12. This is plus 12 plus 12 plus 12. So that is not geometric. And if I 2/3 divided by 1/2, this would be times 1.33. Now let's see if it works here. 4/5 divided by 3/4. Not the same. Not the same. So it's only number 1. Yep, there it is. All right, one more. Quadratic formula. We got 2 different answers for each one. It's just the plus and the minus, okay? Because you always get a plus or minus the square root and blah, blah, blah. So let's put it in standard form first. 7x squared plus 6x plus 9 negative b plus or minus the square root of b squared minus 4 times a times times C over 2A. So let me do the 13 minus 4 times 7 times 9. That ends up getting negative 216 over 14. Square root of 216. It doesn't have a square root, so let's see what we can break it up in. 36 times 6. Yep, 36 times 6 is it. So I'm going to break up that 216 into negative 1 times 36 times 6. That's the tough part right there. Okay, that's the tough part. The square root of the negative 1 is I. The square root of 36 is 6. And the root 6 would still be under there. So I end up here, plus or minus the square root of, nope, 6i on the square root of 6 over 14. I can pull out a 2 out of the 6, and the 14, and I end up with negative 2 plus and minus, I only pulled a 2 out. I didn't divide by 2. Negative 3 plus or minus 3i root 6 over 7. So, looks like that one would be D. There it is. All right, fantastic. Now we're going to go into the 20 questions. It's EOC practice problems 1 through 20 will be the next set. Okay, thank you.